All right, so we are jumping into the next unit already. This is going to be Unit 4. As I told you, this unit is going to build a little bit off of last unit. So not a lot. If you didn't understand Chapter 3, you'll find there will be a little bit of difficulties with this. However, I will tell you that Chapter 5, which we will for sure do, builds entirely off of this. So I'm giving this as a warning. You need to know Chapter 4 to be able to do Chapter 5. So if this doesn't make sense, you got to really work hard to try and understand it. Today's lesson's not too bad though. Yeah. Yeah, there's a switch by the garbage can at the door. You can switch it on. So basically this whole unit and what it's about counting. Not simple counting that you've seen before, but figuring out how many different possibilities we have for something. And you'll see on the AC the light turns green. So something, for instance, those of you who are trying to figure out what you want to wear for the day because you've only got a certain number of school uniforms, you can figure out how many different combinations we can talk about. So we can talk about the different kinds of hoodies, jackets, we can talk about t-shirts, we can talk about pants, and we can figure out the total number of ways that you can do that. So that's what we're going to get in today, starting with a football team. So a certain football team, Hannah's football team, has 3 options for sweaters and 3 options for shorts. And we want to know how many different uniform combinations can we make. Those of you at the back, I have the set of notes here if you want to come grab them. So you can fill it out as we go. So there's 2 ways we can go about doing this. The first way is a tree diagram. You've probably seen something like this before. So we need to look at, first of all, what are the different kinds of sweaters? So our first branch, we could either have red, we could have white, or we could have black. So this row of my tree, this refers to our sweaters. Okay, so these are the different options that we have for sweaters. From each of these, so let's say I went down this branch of our tree and I picked a red sweater. What are the choices I have for shorts?
Red, white, black.
Red, white, black. So if I were to take this path, I could have either red, white, or black for our shorts. Let's suppose instead of a red sweater, I picked a white sweater. What are my options for shorts in this case? Same thing. So if I picked a white sweater, I could have red shorts, I could have white shorts, black shorts. How about if I picked a black sweater? Same thing. I have all 3 of these options for my shorts. Hi, Kareem. In the middle of my class, you should not be making a phone call. Yeah? Your mom knows you're at school, right? Yeah. Well, you don't need to talk to your mom in the middle of my class. So this shows our different outcomes. So if we count the ends of these, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different options that I could pick. And notice how the hard part is trying to read what this diagram is telling us. So if I were to pick option, let's say option 7 here. What would option 7 tell you about the color of sweater that you picked? It's going to be black. How'd you figure that out? Yeah, so option 7 follows this path. I went here, and then I went here. So I've got a black sweater, and I've got red shorts. So that's how you read your tree diagram. You follow a branch down to get your option. I've seen many different variations on how to interpret one of these. You need to be careful with how to read this. What if I said, let's pick option 4 here. So someone else. What does option 4 tell us about my sweater and my shorts? So I heard white, I heard red. I've got, if I follow this path, I've got white sweater, red shorts. So you can go through and you can look at all your different options for these. So notice with this, we figured out how many total options do I have for the sweaters and the shorts for combinations with this. And all I need to do is look at how many branches do I have at the very end. It's 9. So I've got 9 different options that I can pick in order to do this. Any other questions with this? It makes sense? So from something like this, you'll notice as soon as we start to get larger numbers of options, so suppose instead they had 10 different colors of sweaters and 20 different colors of shorts. If you were to try and draw a tree diagram for this, it's going to be rather large, and it's going to take up a whole page just to make that. So thankfully, we have something called the fundamental counting principle. And the fundamental counting principle just says this. If there are A being a variable, if there's A ways to perform one task and B ways to perform another, so A options for sweaters, B options for shorts, then to get the total number, I just go A times B. And that's going to make our lives a whole lot simpler in this case. So if we were to look at the situation we wanted here, I've got 3 options for sweaters, and I've got 3 options for shorts. The total number is 9, which we already figured out from the tree diagram. So this is a whole lot easier and a whole lot simpler to be able to solve a problem. So if I just explain what each of these are. So this is number of sweaters. This is going to be our number of shorts. And this is total options. Man, I can't spell today. Options. Total number of options. So we can now take something that's really complicated. We could say, suppose you went to your favorite restaurant because you want to just go there for some reason. You can have a certain number of appetizers. You have a certain number of main courses that you can deal with. You have a certain number of desserts you could get. You could have a whole range of drinks. So you could just multiply all those together to get the total number of outcomes. And you're just multiplying them together. So this is a relatively easy question for you to be able to do. I will ask you on the test to make one tree diagram, but it's going to be something that's simple. It's not going to be anything that's outrageous numbers. So let's try a few questions that involve this fundamental counting principle. So suppose you have a bike lock and it has a 4-digit code. I have a 4-digit code by rotating 5 wheels. Thumbs off with that. Pretty sure it should be a 4-digit code with 4 wheels. And these digits are going to be from 0 to 9. And we want to know how many different 4-digit codes are possible. So for this code, I've got 4 different digits that I want to pick. And we want to look at how many options do I have for the first number, how many options for the second, how many for the third, how many for the fourth. So if I've got the numbers from 0 to 9, I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 10 different options for each of these. So the first option could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 10 options of what I could have for the first digit. How many options do I have for the second? 10? Yeah. I still have the same numbers from 0 to 9. How about the third? Also 10, also 10. So my fundamental counting principle tells me if I've got A number of options for the first one, B for the second, so on and so forth, all I do is times these together, and this will tell me the total number of options. So 10 times 10 times 10 times 10, this is 4 zeros, so 10,000. So this is the total number of ways or codes that I could have. Any questions on this? Because I have the digits from 0 to 9. So for each of these, I could pick, for this spot, I could have 0, I could have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different options that I could put for each of these. Just skip it and I can come to you later. So this is a situation where we have no restrictions. I'm not saying there has to be a specific rule with that. But now suppose each digit can only be used once. So if I pick the number 7 in the first spot, I can no longer pick that number. We want to know how many different codes are allowed. So again, I've got 4 different digits. And you need to think, how many options do I have for the first number? Well, there's no restriction on the first number. So therefore, I could have any number of those 10 digits. Again, this is not us picking the number 10 at the beginning. This is the number of options for that. So once I've picked that first digit, because I'm only allowed to use that number once, whatever number I picked in the first spot can no longer be picked in the second. So how many options do I have left for the second spot?
9.
I've got 9. And now I've used up 2 digits, so then I've got 8. And I've used up 3 digits, and now I've got 7. Mm-hmm. Why can we put the same numbers here? Because there's no restriction. So I could pick the numbers 1, 1, 1, 1, and that's okay. Whereas here, if I picked some digit for the first spot, I cannot have it for the later ones. No, you don't have to pick 4, but you could pick 4. So if suppose in my digit I put 3 as my first digit here. So the second digit, I could still have 0, 1, 2, 3, 4, 5, 6, 7, or 8, 9. I could pick any one of those 10 for the second one. So it doesn't matter what I put here. Whereas for this second one, if I looked at those numbers, if I put 3 as the first digit, I'm not allowed to use that anymore. So I have to cross that out, and my only options are 1, 2, 3, 4, 5, 6, 7, 8, 9. I've only got 9 options left to put for the second one. Does that make sense? So this is something that we call a restriction. You place a restriction saying, I cannot use something again. Any other questions with that? Oh, I need to actually answer this first. So if I multiply these together, we get 5,040. So this is the total number of options if I'm restricted on what numbers I can pick. So that's some examples of how we use the fundamental counting principle. It's how many options for this times how many options for this times how many options for this. So here we are going to see some involvement with what we learned last chapter. So I said this was going to show up. So I've got two different situations. This is just a recap from last time. If two things are disjoint, that means I've got two separate circles. So if I want the number of elements in A or B, it's going to be the number of elements in A plus the number of elements in B. This is an N. So this is if they're disjoint, meaning if I want to know how many are in A and B, I just add those two things together. If they are not disjoint, so if they are not disjoint, I'm going to have an intersection in the middle. So for this case, did it say C and D? Yeah. So the number in C or D is going to start out similar. So the number in C plus the number in D minus the number of elements in C and D. So I'll just add this center region on there. And we are going to use this when we're talking about finding the total number of outcomes. So these I will give you on the formula sheet. You don't have to memorize them, but you will get something like this. As promised, we're going to deal with a deck of cards. Yeah. So we want to know the number of possibilities of doing these next two things. So what are the number of possibilities to draw a red card, a red face, or an ace? Do you know what it means by a face card on a deck of cards? So this could mean either you're dealing with the king, the queen, or the jack. On the test, I will give you the deck of cards on a piece of paper. So you don't need to have this remembered if you don't know it. It's also from the textbook. So if we want to figure this out, I've got two options. Notice here, it's or. So let's think about this. How many red face cards are there? That's what we need to first think of. So I've got, let's see, I've got the king, queen, jack of hearts, and I've got the king, queen, jack of diamonds. So I've got 6 different red face cards. And how many aces are in a deck of cards? There's going to be 4, 1 from each suit. What we need to think is, are the red face cards and the ace cards mutually exclusive? Are these two things disjoint? So is there any red face card that is also an ace? No, those ones are not the aces or the red cards. So they're an ace is just an ace. These are your king, queen, and jack of the hearts and the spades. Because there's three with the diamonds, 3 with the hearts. So I could have the king of a heart and a diamond. I could have a queen of a heart and a diamond. I can have a jack of a heart and a diamond. For Monday, I'll try and find the formula sheet for you so you can see what the deck of cards is. So in this case, they're disjoint. Meaning I cannot have two things in the same set. So using the principle we talked above, the number of A or B, I'm going to write out the formula so you can get used to seeing this. So the number in A plus the number in B, well, if this is set A, it's going to be 6 plus set B, which is 4. So the total number of outcomes is 10. Questions with this? Yes, what's your question? A question. Yeah, that's why I said I can show you later in the textbook. We have it shows the deck of cards. You can see them all. And then it'll be easier to see what they are. That'll definitely help. That'll be the next one. So these two are disjoint. And because they're disjoint, I can just say what's the number in the first set and add it to the number in the second set. Yeah. The number in A is 6 and the number in B is 4. So now let's look at either a red card or a 10. So in thinking about a deck of cards, how many red cards do we have? There's 52 total. So half of them are going to be red, half of them are going to be black. So it's half and half, so the number of red cards is 26. All the hearts, all the diamonds. And how many 10s are in the deck of cards? 4, one in each suit. Now the question is, do we have any red cards that are 10? Yeah. How many? 2. I've got a 10 of hearts, and I've got a 10 of diamonds. So if I'm dealing with this, and looking at our equation, so the number in A or B, in this case, they are not disjoint. What's that? You know what? I love that door. Do you know why I love this door? Because no one can sneak in or out of my classroom, which was a problem back when it was fixed. Because students just like to come in and out of my class for some reason. So because they're not disjoint, we need this. So this is the other half of this equation. But we've already determined this. So don't be freaked out by the equation because we've already figured this out. The number in set A is the red cards. It's 26. The number in B, set B is the 10s. So we said there's 4 of them. And we are going to minus the number of elements that are red and 10s, which you already said it's 2. So now just add those up. So you get 28. Questions with this one? Okay. So to kind of compare this to last unit, what you should be thinking is something along the lines of this. So if I'm dealing with the universal set of all cards, I've got 2 sets. Red face cards and I've got the aces. And these 2 are disjoint. There is nothing that's a red face and an ace. So in here I've got 6, in here I've got 4. That's the number of elements. Not what the elements are, it's just the number of elements. what would the diagram for this case look like? Yeah, they'd have an intersection between them. So we've got red cards, and we've got 10s. And now there's an overlap region in the middle. So in this case, there's 2 that are in here, so therefore I needed to use that to calculate it. So this is what you should be thinking in your head. You do not need to draw this, although if you did, I would give you a part mark for that. So if you wanted to draw it, you could. But this is what you need to think in your head. Is there this overlap region? Is there an overlap? Is there something where there's an element that is in both sets? If there is, it tells you this equation. If not, it tells you the other. Yes? On this diagram? So 26 is the number in this whole circle. So out here is 24, yeah? And how many would be here? Yeah. There you go. Any guesses what would be on the outside here? Just to see if you remember from last unit. No, you don't have to. I'm just asking if you remember what you would put out here.
All the numbers that are needed.
Yeah. So if I've got 52 cards total, 52 minus this will give us the outside. You don't need to for this question. I was just seeing if you guys remembered that. So that's the first section.